Hello Radiant Scholars! Today we're going to be learning about functions. So, what is a function? Well, a function is like a machine at a conveyor belt. You put something in, and then you get something out. And so a function is something that maps inputs to a single unique output. Something like this. And so typically we write something like this as y equals f, and then in brackets x, and this just says that y is a function of x, and you can relate this to graphs as it is saying that y will take a value based on whatever input x you put in. We could say something like f of x is equal to x squared, and this means that for every x we put in, our output is going to be the input squared. Let's say we put in 1, we'll get 1 out, and we put in 2, we'll get 4 out. And so there's also inverse functions, which are basically the reverse process of a function. The regular function maps the input to the output, and then whatever output you get back, if you put in the output into the inverse function, then you'll get back the input. So it's basically reversing what the function does. There are also composite functions, which are basically two functions combined together, or a function that acts on the output of another function. And so these two look something like this. Oh, I think I'm covering it a bit. And this. And so that's the inverse. And this is saying that whatever g of x outputs, f will take it and output it using the function f. That might be quite a lot to take in if you haven't seen this before, but we could definitely just hop right into some questions. And so here we've been given the rules of two functions. So f of x is equal to 2 over x squared. And our first part says to find f of minus 5. And so to find that, we just input minus 5 into the function f. And what that will do is wherever x is in the function, we'll replace it with our input. So we'll get 2 over minus 5 squared. And so simply our answer is 2 over 25. Now we have a composite function for part B. What I like to do is break this down into two separate functions. Well, I suppose it is already two separate functions, but I'll make it clearer by saying f of g of 1, like separately. And now I can work out g of 1 on its own, which is 4 times 1 to the power of 3. And that's 4. Now all I have to do is put in 4 into the function f, which is equal to 2 over 16, equivalent to 1 over 8. Now for our next question, we're asked to find the inverse g function. And the way to find that is a little harder than just substituting things in. And so what I do is I take the g function and replace g of x with y. Then I'll write out its rule. And so my aim with this is to get x on its own. So as we can see, x is over here. And so we'll have to move things around in this equation in order to get x by itself. So we can begin by multiplying 5, subtracting 2, and then squaring both sides. And I skipped a few steps, but I basically just expanded the double brackets that would come out of that square. And so now we have x is equal to 25y squared minus 20y plus 4. So now what I do is replace x with inverse g of x, and then replace all the y's with x. So since we have that, I'll write it like this. Well, I looked at the mark scheme and it said you could keep it as 5x minus 2 squared, but it doesn't hurt to expand it out like that. Now, the reason why this works is because g of x is, as I stated, our output. So like y equals something. And then when we substitute and rearrange to get x, we're basically ripping x out of the rule because x is the input. And by rearranging it, we effectively make x the input, or which used to be the input, now be the output of g inverse of x, or inverse g of x, however it's said. And now we've got a little bit of a break, I suppose. Well, I can't really say a break because it's actually our last question, but solve g f of x is equal to 3. Now, that might be a little harder than I expected. So let's write it out. Now we know that f of x is equal to 3x plus 4, so we can just put it straight into g. And then use the function g to write it out. So remember that wherever x is in the function, we'll replace it with the input. And so g of x is equal to this right here. Now we want to solve it for it being equal to 3. Multiply both sides by 5. Subtract 2. Square both sides. Subtract 4. And then finally, divide both sides by 3 to get x equals 55. And that looks pretty good. And so if you have a calculator, you could check if x equals 55 actually is a valid solution. So just put f of 55 in, and then g of whatever you get, and see if it is equal to 3. And that's actually all I have for today for functions, because it's not such a big topic, but it is quite important, I would say, yeah, because it could be related to other topics like graphs, as I stated before. But questions involving it directly don't come up too much. However, they are still very important to know. So definitely do not slack on these. And I will see you in the next lesson, Radiant Scholars.